So far, we discussed the two kinds of distribution. One is exponential distribution. The other one is Poisson distribution. The question is, when do you use Poisson distribution and when do you use exponential distribution? So both distribution, we use both distribution to calculate the probability. When we talk about in-arrival time, the time between two customers, either greater than something or less than something, we are going to use exponential distribution. On the other hand, when we look at the number of customers in a period, then we use Poisson distribution. For exponential distribution, we need to know two pieces of information. One is lambda, arrival rate. The other one is t, time. So lambda t have to be consistent. For Poisson distribution, we need three pieces of information. One is lambda, the other one is t, and the last one is n. N is the number of customers in that period. So now let's look at some exercise questions. Exercise question 1. This is from the textbook. A fast food restaurant is interested in starting its arrival process. During the busy lunch period, they have observed an average of 20 customers per hour. It's Poisson distribution or Poisson process. Look at question 1. If a customer has just arrived, what is the probability that the next customer will arrive in 10 minutes? So again, if a customer has just arrived, what is the probability that the next customer will arrive in 10 minutes? So here we're talking about the time between this customer and the next customer. So in arrival time. So we can use exponential distribution. So in order to use exponential distribution, we need to know the value for lambda and a t. So t here is obvious, 10 minutes, obvious. So what is lambda? So lambda says 20 customer per hour. Okay, 20 customer per hour. So we know lambda, we know t, we can apply the formula. However, as I said, in order to apply the formula, you want to make sure lambda and t are consistent. So here, t is 10 minutes, lambda is 20 per hour, not consistent. So we have to convert. So lambda is 20 customers per hour. The question is about the time between this customer and the next customer. So we use exponential distribution. So lambda is 20 customers per hour. So we want to convert lambda from 20 per hour to how many per minute? So divide by 60. So you get 1/3 per minute. That is a lambda. T is 10 minutes. The question is, what is the probability that next customer will arrive in 10 minutes? Next customer arrive in 10 minutes. In other words, the in-arrival time between this customer and next customer is less than 10 minutes. So this is the right formula to use. So we plug in the value for lambda and the t. As I said, these two have to be consistent. We got a number of 0.9643. So in other words, there's a little over 96% of probability the next customer will arrive in 10 minutes. So for this particular question, we use the exponential distribution. Question 2. What is the probability, against probability, of two customers arrive in 5-minute window? Two customers arrive in 5-minute window. Two customers in 5-minute window. So number of customers in a time period. So it looks like we're going to use a Poisson distribution because it's talking about number of customers in a time period. So again, two customers, that is n. N is equal to 2. T is equal to 5 minutes. So two customers in 5 minutes. So this question is about the number of customers in a period. So we use Poisson distribution. So we use a formula. As you can see, this is a little bit complicated formula. And this formula requires three pieces of information, n and t and lambda. So lambda is again the 1/3, t is 5 minutes, and n is 2 factorial. So you do the math, you get 0.2623. So basically, there are a little over 26% probability that you will be able to observe exactly 2 customers in a 5-time window. So first question, we applied exponential distribution because this is talking about the in-arrival time. The second question, we used Poisson distribution because this is talking about number of customers in a time period. Now let's look at exercise question 2. For exercise question 2, we actually have multiple sub-questions. So we have 7 sub-questions, 6 actually. So first of all, let's read some general information. Customer in-arrival time follow exponential distribution. In average, there are 90 customer arrivals per hour. So you can see when you read the question, you can see we see there are 90 customers per hour. So this looks like it's a lambda. So lambda basically equal to, look at the first question, question 2.1, what is the arrival rate per minute? So this is lambda equal to 90 per hour. So this is given information, 90 per hour. The question is talking about arrival rate. It's also asking about lambda, but the per minute lambda. So we have the information lambda equal to 90 per hour. We want to convert lambda to how many per minute. So we divide by 60. So we have 1.5 per minute. So lambda equal to 90 per hour, also equal to 1.5 per minute, equivalent. Second question, what is the probability that the next customer will arrive in 3 minutes? Next customer arrive in 3 minutes. We're talking about the time between this customer and the next customer in 3 minutes. And basically, we're talking about in-arrival time. So we can use exponential distribution. So the question is about the time between 2 customers. So we can use exponential distribution. For exponential distribution, we need 2 pieces of information. One is lambda. So lambda is 1.5 per minute. We also need a t. T is 3 minutes. Again, we use that 1.5 per minute. We didn't use 90 per hour for consistency reasons because t is 3 minutes. So we need to figure out the arrival rate per minute. Then we apply the formula. So how likely the in-arrival time is less than 3 minutes? So this is the formula. We plug in the value for lambda and the t. We do the math, get 0.9889. So in other words, there's that little over 98% probability that next customer will arrive in 3 minutes. Question 2.3. What is the likelihood that the next customer will arrive in 1 hour? So look at the question. How likely the next customer will arrive in 1 hour? Again, this is talking about the time between this customer and next customer. We're talking about the in-arrival time. So obviously, we can use exponential distribution. So the question is about the time between 2 customers, so we can use exponential distribution. In order to use exponential distribution, we need 2 numbers. One is lambda, one is t. So what is lambda? Lambda is 90 per hour. T is 1 hour. So here you see, we use different lambda. So in the previous question, question 2.2, we use lambda 1.5 per minute. But in question 2.3, we use lambda 90 per hour. The reason is in question 2.3, the t is 1 hour. That's why we have to use arrival rate per hour to be consistent. So per hour, hour, per minute, a minute, have to be consistent. Then we can apply the formula, how likely the in-arrival time is less than 1 hour. So less than 1 hour, this is the formula to use. Plug in the right value for both lambda and t. You do the math. So it's basically this term is very, very small. You can almost ignore it. That's why we got 1.0. It's almost 100%, almost 100% probability that next customer will arrive in 1 hour. Let's move to the next sub-question, question 2.4. What is the probability that there are no customer arrivals in the next 2 minutes? Again, how likely that there are no customer arrivals in the next 2 minutes. For this question, let's think about it. So shall we use exponential distribution or shall we use Poisson distribution? In this case, this is a special case. In this case, we can use both, and we'll end up the same solution. So first of all, when you read the question, it says no customer arrival in next 2 minutes. In other words, the time between this customer and the next customer will be longer than 2 minutes. The inner arrival time between this customer and next customer will be longer or greater than 2 minutes. So here, you can view the question as talking about time between two customers. The time between this customer and next customer will be longer than 2 minutes. That's why we'll have no customer arrival in the next 2 minutes. This is equivalent. No customer arrival in the next 2 minutes implies that the next customer will arrive after 2 minutes, so greater than 2 minutes. So no customer arrival in 2 minutes is same as inner arrival time is more than 2 minutes. So we can view the question as time between two customers. So we can use exponential distribution. So what is lambda? Lambda is 1.5 per minute. What is t? T is 2 minutes. So 1.5 per minute, 2 minutes, consistent. Apply the formula. Here, the formula, we use this formula. The reason is we're talking about inner arrival time greater than a number. So we use exponential function, a negative lambda t. You plug in the number, you get 0.0497 and 9. This is a probability that the next customer will arrive, no customer arrival in next 2 minutes. So we can apply exponential distribution. Yeah. On the other hand, you can also look at this as a Poisson distribution because it looks like we're talking about no customer arrival in 2 minutes or zero customer arrival in 2 minutes. Zero customer arrival in 2 minutes, number of customer arrivals in a period. So we can apply Poisson distribution. So we can also view the question as the number of customers in a period, zero customer in 2 minutes. So we apply Poisson distribution. So by applying the formula, so here, zero customer, that's why n is equal to 0. Lambda, same, 1.5. T, same, 2 minutes, 2 minutes. So we do the math, you get 0.04979. So you can see these two numbers are the same. So solutions are the same, regardless which distribution you use. You can either use exponential distribution or use Poisson distribution. They end up with the same solution. So question 2.4 is a special case. For this question, when somebody asks you about the probability that you will see no customer in a period, you actually can apply those distributions to figure out solutions. Okay, only for no customer arrival in a period, only for this type of question. For most other questions, you either have to use exponential distribution or use a Poisson distribution. But when you see the question structure like this, there are no customer arrival in a time period, then you can consider either use exponential or Poisson. But regardless of which one you use, the solution will be the same, like in this case. Now we have two more questions, question 2.5 and question 2.6. So first of all, look at question 2.5. What is the likelihood? What is the probability that there is exactly one customer arrival in the next 2 minutes? Exactly one customer arrival in the next 2 minutes. So one customer in 2 minutes. It sounds like how many customers in a period. So obviously, for this question, we can use a Poisson distribution. The question is about the number of customers in a period, so we can use Poisson distribution. So lambda is equal to 1.5 per minute. T is at 2 minutes. So n, how many customers? So one customer arrival. So n is equal to 1. So we have lambda, we have t, we have n. We can apply the formula, plug in all the value, we'll do the math, we get 0.1494. So in other words, there's a close to 15% probability that there will be exactly one customer arrival in the next 2 minutes. The last question, question 2.6. What is the probability that there are exactly 2 customer arrivals in the next 2 minutes? So question 2.5 is exactly 1 customer arrival. Question 2.6 is exactly 2 customer arrival in the next 2 minutes. You can see these 2 questions are structured similarly. That means for question 2.6, we can also apply Poisson distribution. The question is about the number of customers in a period, so we can use Poisson distribution. So lambda is 1.5 per minute, t is 2 minutes, n is 2, 2 customers, n is equal to 2. So by applying the formula, we plug in all the numbers, we do the math, it's about 0.2240. In other words, there is a roughly 22% chance you will see exactly 2 customer arrivals in the next 2 minutes.